Okay, section 7.2 is the addition counting principles. First group of, notation or sets of notation that I want you to understand is A union B. That's how we read that symbol right there. That, looks like a U. A union B. The word or can be also substituted, so you might see A or B written down, and that means exactly the same thing. It really means all elements in set A or set B or both. All the elements that are in A or B or both. So if we're looking for A union B, we're looking for every element that's in both those sets. Now, another symbol is what looks like the upside down version of the union symbol, and it is read A intersect B, and sometimes we substitute the word and, so it might be A and B. That means the same thing. In this case, we're only looking for elements that are in common to both sets. Sometimes we use the word overlap. Where do they overlap? What do they have in common? That kind of thing. Another term you need to know is, or phrase, mutually exclusive. Something that many of you should be until you graduate college. Another term is disjoint. That term means the same thing as mutually exclusive. Sorry, I got interrupted. Anyway, let's see where I was. I was talking about mutually exclusive and also disjoint. If you talk about Venn diagrams, a Venn diagram is when we draw circles to represent sets. VENN, in case you are, looking at billboards or T-shirts or television commercials. But set A and set B do not have anything in common. That's why we know that they are mutually exclusive or disjoint. Now, what you'll see is A intersect B is equal to the empty set or the null set. That means that it's completely empty. There's nothing in it. That is not a zero. That is an empty set. In this case, and if you want to find the number of items which are in A or B, in A union B, you simply add the number of items that are in event A plus the number of items that are in event B, and that is the number of items in the union. Well, it makes sense because there's no overlapping. And if you want to change this to a probability, then take the probability is just the same thing that we had in the last example, except you divide each one of the items by the number of items in the sample space. That's what the capital S stands for. So that makes sense. If you want to change the number of items in an event to its probability, you just divide by the number of items in the entire sample space, or all the outcomes. And that changes it to a probability. Same thing over here. So the probability of A or B is the probability of A plus the probability of B. Now, I'll give you an example. The probability of rolling a sum of 7 or a sum of 11. Well, probably need to look at a sample space for this. So we'll have to build a sample space for the sum. So let's look at almost what looks like a matrix, but it's not. All I'm doing is trying to figure out what the sums would be. So, I don't care whether you call that first die and that second die or whichever you want. But if I rolled a 1 and a 1, the sum would be 2. A 2 and a 1, 3, 4, 5, 6, 7. Well, go down this column, same thing. 3, 4, 5, 6, 7. 2 and a 2 would be a 4, 5, 6, 7, 8, 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, 8, 9, 10, 9, 10, 10, 11, 11, and 12 would be. So here's the sample space for all the sums of combinations of rolling dice. And so I want to know the probability of rolling the sum of 7. Okay? Well, there are 6 of those out of 36. So I'm going to write this down on the other sheet, and then I'll show that to you in a minute. The probability of rolling the sum of 11, 2 out of 36. You are going to notice that those events are disjoint. They are mutually exclusive. They do not have anything in common. So back over here on this screen, we took a probability sum of 7, 6 out of 36. 11 is 2 out of 36, so that is 8 out of 36. Or we can reduce that, right? 4 goes into the top, and 4 goes into the bottom. So it's a probability of 2/9 that would occur. Well, what if they do have common ground? What if A intersect B does exist? How does that change things? Well, we have the number of items in A union B, or A or B, is the number of items in A plus the number of items in B minus the number of items in the intersection. You ask, why do I have to subtract that? Well, because when you count all the items in here and all the items in here, you have double counted the middle. So you're going to subtract it once in order to take care of that. Obviously, if you divide everything by the number of items in the sample space, you change this formula into a probability formula. The probability of A or B equals the probability of A plus the probability of B minus the probability of the intersection. This formula can be used in many different types of situations or problems. What happens when the intersection is empty so that the probability of A intersect B is 0? Oh, look, it's the same formula from the last situation. So this formula right here is a more generic formula for different probability situations. This one is a specific formula only to mutually exclusive. Well, what happens if we have a situation where we want the probability that we roll doubles or a sum of 8? Well, we can go back to our sample space for sums and look at that. The sum of 8, right, that was 1, 2, 3, 4, 5. 5 out of 36 for that event. So I can write that down. 5 out of 36. Doubles. Well, doubles would be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay? So those are the situations. Now, the only reason I'm circling these, not because I want those sums, but those are the combinations for doubles. There are 6 of those. So I wrote that down in my probability. 6 out of 36 for the doubles, 5 out of 36 for the sum of 8. But I want you to notice something. They overlap in one spot. So we have counted that situation twice. Therefore, in order to finish this off, we must subtract that 1 out of 36 from that since we counted it twice. So 6 plus 5 is 11 minus 1 is 10 out of 36, or 5 out of 18, is the probability of getting doubles or a sum of 8. The last thing I want to talk about is complementary events. Complementary events are things like making the free throw or not. You missing the free throw. Rolling a number, the 7 on the number die, single number die, or not. Oh, sorry. That would be impossible. Rolling I'm so funny. Rolling a 6 or not. Now, these particular events, complementary events, add up to 100%. Well, that makes sense. If you're an 80% free throw shooter, then you miss 20% of your free throws. When you flip the coin, it's a 50% chance of getting heads and a 50% chance of not getting heads. So they add up to 100%. Complementary events, very easy. That's a very useful thing. Make sure you use it as often as you can. The complement, here's another situation I should ask you about. Okay, let's suppose that the numbers 1, 2, 3, 4, 5, and 6 are the ones that we're using on a number die. What's the probability that x is that we get a 1 or a 2? Well, that's I could figure out 1 or 2. What if I said what's the probability that x is greater than 2? Now, isn't that the probability that x is equal to 3 or more? Okay. Greater than 2 would be the same thing. Oops, sorry. Greater than 2 would be the same thing as 3 or more. But we can also do something else. Even though I'm looking for greater than 2 or greater than or equal to 3, I could still figure out the probability that x equals 1 and the probability that x equals 2, add them together, and even though that's what I'm not looking for, I can find its complement. So once you figure out these two things, okay, so the probability of rolling a 1 is 1 out of 6. The probability of rolling a 2 is 1 out of 6. Right? So the probability of rolling a 1 or a 2 is 2 out of 6, or 1/3. That must mean that the complement would be 2/3. Whoa, I can't see any of that on the screen. How useful is that? Sorry. So the probability that x equals 1 is 1/6. 2 is 1/6. Their sum is 1/3. Therefore, the complement would have to be 2/3, because these two have to add up to the number 1. So don't think it's just about free throws and missing free throws. It could be about whole sets and what's faster. Is it faster to find 3, 4, 5, and 6? Or is it, and I know this is a very simple situation, so it's not real complicated, but in some of these situations, you're going to find that it's easier to find 1 and 2 and then just reverse the process to get the complement. And I would remember this little trick because it'll come in handy for you. And those are my notes on